Good morning, everyone. I've met a lot of you before, and I think many of you have been to the briefings that we've had out in California. How many of you have actually either done a review or saw me tear down the Z800? Not quite everyone, almost everyone. Looks like everyone does. So the good news is that means I can shorten things up a little bit, because I was going to do some of that if we didn't have as much knowledge of the platform. But before I get started, I think an interesting place to begin, since Jim talked about the fact that I've been here forever, I'm ancient, is to tell you why is HP in Fort Collins? Why Northern Colorado? How did it all begin? And the interesting story here is that Bill Hewlett and Dave Packard built their first outside of California plant in Loveland, Colorado, just to the south. So about 8-9 miles to the south here. And the buildings are still there. Unfortunately, they're now empty. But it started in 1959. As part of that group, in 1969, a small R&D team began working on an engineering calculator that at the time was very much state-of-the-art because it could do things like sines, cosines, and logs. And it literally was the first desktop something that could replace an engineer's slide rule. Now, you'll probably recall that about 3 years later, after that, HP came out with the HP 35 calculator, a handheld version of that. But some of its genesis actually began here in Colorado. Well, that group actually began to take that idea of a calculator and expand it. And through the 70s, they created actually a small business unit called the Desktop Calculator Division. The Desktop Calculator Division grew into the Desktop Computer Division in the late 70s. In fact, when I joined in 79, I joined on with the Desktop Computer Division. And our principal goal was to develop computers for engineers to do instrumentation. And some of you may recall HP helped drive a standard through IEEE. HPIB was a standard for which you could interface instruments to computers and collect data. What? IEEE 48. Yep. Johnny remembers the original IEEE spec. We call it HPIB though. It was never IEEE 48. HPIB. Anyways, so that's how I got my start here. You'll also recall that roughly around the 1980s time frame, beginning of the 80s, was the beginning of what I'll call the workstation class of products. And who were the original founding members? Apollo, Sun, HP, IBM were the original.
Digital. Stellar.
Yep. There was Digital. There was a couple other small ones. There was a company down south. I forget the name that was building some workstations back then. Might have been Prime, yeah. But there were a number of categories. But the dominant ones became really Sun, Apollo, HP, and Digital. SGI came later. SGI came in the late 90s, late 80s. I'm sorry. And what were those systems? Those systems were completely vertically integrated solutions. They started out with the Motorola 68000 processor family, and then in the late 80s it migrated to RISC. And everyone had their own version of RISC. Everyone had their own version of Unix that they put on top of that. And every ISV out there that wanted to put an application on a workstation had to have a unique version for each of those vendors. It was a successful business, and HP was part of that successful business. In 1989, HP acquired Apollo, and we brought Apollo and HP, but Fort Collins was the nucleus for that initial workstation category. We have a museum downstairs, and you guys are going to get to see it. Okay, I'll literally show you the lineage of those products. What was interesting about that time is that all those companies were all called vertically integrated on technology. Here in Fort Collins, we had a lab of almost 500 people doing graphics. That's all they did. Half of the lab was doing software and drivers, and the other half was doing silicon. We were doing GPUs. We'll show you some of those in our museum downstairs. But we had that level of expertise. We had another 250 people doing chipsets. And then we leveraged across HP, because there was a large effort across HP to do PA RISC. We leveraged that processor technology, but we did unique chipsets just for workstations. So we did our own silicon. In fact, the silicon was actually built on this site. So today this site is split between Avago and HP. So as you drove in, you saw that there's two companies here. Avago actually was Agilent, and before Agilent it was part of HP. So the 3 buildings on the west side of the campus here are actually integrated circuit labs and manufacturing facilities. We actually built the chipsets and the graphics chips here in Fort Collins. Not only did we design them, we built them here. So we could actually get the silicon off the production line and begin to test it pretty much real time.
How big was the fab?
You know, I don't know the specific size. I can't tell you the specifics. And I don't know what it is today because once HP split off Agilent and then Avago acquired that piece of Agilent's business, it's changed a lot over there. So I don't remember exactly how big it was. The point I'm trying to make though is that we as a business, the workstation business for HP was incredibly vertically integrated. We did operating systems, we did HPUX, we did drivers for OpenGL, we did chipsets. We called it firmware, it wasn't called BIOS, it was called firmware. We did, you know, the machine interface. We did all the pieces and parts. And then as you recall, in the mid-90s, you know, that business was pretty strong and you're selling a workstation, $25,000 was a typical workstation price. In $1995, move that into today's dollars, that's a lot of money to spend on an engineer's box, but people would spend it. And the business model was very complex. I mean, organizations, the workstation organization was well over 1,000 people. Think about graphics and chipsets and then building the system itself. It was pretty complex. HP recognized as the late 90s began to emerge that RISC would run out of gas for workstation class customers. In fact, the industry realized that. And there was an emergence of Itanium and say, we're going to move the industry to Itanium. And then there was those little guys down in Texas called AMD who said, well, no, we can put 64-bit in x86. And we did a lot of work to really understand what was happening in terms of that transition and that change. And Jim, Jeff, and I were really involved with, I was working on the R&D side and program management, Jeff on the marketing side, really understanding what that transition would mean to the business. We said, wow, x86 is probably going to have a dominant role to play. And we began a transition. We began a process to look at the business and say, RISC is going to have a life and we have a great business, and you're going to see a bunch of those RISC machines downstairs. But it probably has an ending point because it's going to be replaced with commodity-driven environments. In the late 90s, we had to make a very difficult choice. We had this incredibly rich history of graphics here, and we saw the emergence of ATI and NVIDIA. And it was driven in large part by consumer. Consumer graphics was exploding in the late 90s. And what it was enabling was cost that was much cheaper. And we looked at our investment model, and you looked at the investment in foundries and things like that, and you said, no, we can't be in this place anymore. We divested ourselves of graphics. We said we can't do that. As we approached 2000, we divested ourselves of chipset development. We said we can't do that. We also divested ourselves of manufacturing. We had large manufacturing facilities that were HP owned. We said we have to go to contract manufacturers. So we went through a transition, and we began to recognize the need to look at how could we drive value in what has now become a commoditized world from the core technology point of view. Because this box today, Intel Xeon processors, NVIDIA ATI graphics, it's Intel chipset, it's Seagate hard drive. I mean, you can go down the list. It's a whole bunch of vendors that you buy from and then you assemble it. And we embarked upon a strategy that says that we're going to move through this transition. We're going to take that rich history that started in the early 80s. In fact, you could actually argue it started back in 1969 when that group in Loveland created that first engineering calculator that we had. And we're going to take that experience and that expertise and we're going to apply it to this commodity space. And Jim actually mentioned an example of how we could apply it. And we talked about DreamWorks. DreamWorks came to us and said, we can't stay in SGI. The platform is out of gas. We've got to go here, but we can't get any of our stuff to work on Linux. The drivers just aren't there. Nothing will work. We took, as Jim said, the HPUX OpenGL